Hello, today you're going to learn how to tell the difference between a relation and a function. So to start with, we want to note the two differences. So a relation is any set of points that connect two variables. A relation can be, but doesn't have to be, expressed as an equation. So you can just have dots on a graph, for example. On the other hand, you have functions, and a function is a special type of relation where no two different coordinates have the same x coordinate. So in other words, if you have one x value, right, that should only produce one possible y value. You can't have one x value that produces two separate y values. And we can test whether a relation is a function in a couple different ways. One being out directly, so when a value of x is substituted into the equation, you should only have one value of y. Or you could look at things geometrically or graphically, where if you draw a vertical line on the graph of the relation, each line will cut the graph only once. So let's have a look at some examples. So in this first one on the left, we have the equation y is equal to x plus 3. Now if I am going to draw a vertical line, we see that it is only cutting the graph once. So then we can say that this then is a function. I guess one thing to make really clear is that all functions are relations, but not all relations are functions. Okay, so in this case it's a function and also a relation, but we're interested in functions primarily. We go to our second one here, and we notice that at this spot, if I go down, I'm only going to cut it once. I'm also only going to cut it once if I'm here. Even if I go along the y-axis, I'm never going to actually cut my graph. That's okay, because as long as we're hitting it at most once for any particular vertical line, that means this is a function. Now if we look at our third one, here we have a whole bunch of points. Right, so we don't have a normal graph. So if we look at this most leftmost point, it only hits once. So you go, okay, maybe it's looking like a function. However, if we go down and find this here, right, so if I drew that straight, it goes through two dots. Right, hopefully you can see that. And what that means is I have one x value, right, because we've gone a certain amount across, one x value, but we've got two possible y values, right? And that cannot happen, so that means this is a relation only. Okay, it did not pass the vertical line test. We look at this fourth one, and here I go down, I cut it twice, so this is also just a relation. So we also can try and decide whether things are relations or functions by looking at equations. So in this first one we have y is equal to 3x minus 1. Right, and hopefully we know that 3x minus 1 is really just a linear line. Okay, so we've seen from our previous slide that we should know that 3x minus 1 is a function. But also if I substitute any x value in, 1, 2, 3, negative 5, right, I'm only going to ever produce one possible y. So that means that this one is going to be a function. However, if we look at our second one over here, if I want to find out how many, like what my y value would be for certain x values, I can rearrange that to be y is equal to plus or minus the square root of x. Now what that means is for any x value that I sub in, I could have either the plus version or the minus version of it. So that means it's producing two separate y values for one particular x, which means this is a relation. On this third one, however, we have, I know I have a squared here, but we're trying to decide how many y values there are for each x. Now if I put in a negative 1 for my x, right, I would get negative 1 squared, that makes a positive 1, minus 9, that should give me a negative 8. Right, so I'm only going to get one possible y value, because no matter what I'm putting in for my x value, y will always be one particular number. There is no plus minus to create and find my y value in this case here, which means this should be a function. So a couple extra graphs at the bottom here just to make sure things are a little bit okay, like a bit smoother. So here I'm going down, I cut across twice. This is going to be a relation, doesn't pass our vertical line test. And then in this last picture, we're going to do a horizontal line test as well. Just going to, I guess, make sure you recall that if it's open, that means we have that point is not included, whereas this one here, which is filled in, means that we are including that point. So if I go down here, I'm only hitting my graph once, and that's at this spot because we don't actually include that little bit here. And that is open, which means it's not included. So this line here is only hitting it once. However, if we go up to this point, we see that they're both included, so we have two y values for one particular x value, which means this is also a relation. Pause at this moment to have a little think about whether you think a circle is a function or not. I'm going to get straight into it and go, well, it doesn't pass a vertical line test, so it is a relation. Later on in this topic, we're hopefully going to get into the equations of circles, and we'll see some sort of relationship between something that looks a bit more like this here, the x equal to y squared, and having a plus or minus, and we'll be able to see the connection between the equation and the graph. But yes, a circle is just a relation. A couple more questions for you to have a go at. Maybe pause at this point so that you can have a think about it. Maybe chat to the person doing the class with you nearby. And then once you're ready, unpause the video and we'll go through this ourselves. Okay, so is it possible for a function to have more than one y-intercept? No, because then one x value, when x is equal to 0, would produce two possible y values. So I've got a little graph here. So we've got when the y-intercept there are two y-intercepts, that means it's failing the vertical line test. So that means you're not going to have a function if you've got something with two y-intercepts or more y-intercepts. The other one is, will the graph of a straight line always be a function? You could be forgiven for saying yes, always. However, there is one little thing, and that is vertical lines. So if you have the equation of x equal to some number, you'll have a vertical line, and that means you have an infinite number of y values, which is not allowed for a function. However, any other straight line will produce a function. Have a go at some questions.